Here's page 7 of exponentials. First it says to use the distributive property, FOIL, or take a look at your book. These are really good to know for SAT also. SAT and vestibular love these kind of problems. Remember that when you have this expression, you can distribute the A between the B and the C. So this is the same as AB plus AC. If you have two binomials like this, then you're going to do FOIL. So you're going to do A times C and A times D, and you're also going to do B times C and B times D. Okay, so that's equal to A C A D B C B D. You can also do it like in the box form, which is you have one binomial across the top, A plus B, the other binomial across the side, C plus D, and you just like multiply each one and put it in the box here. So I have AC, I have BC, I have AD, and I have BD. Those are all the possibilities. And then I just write it out. AC plus BC plus AD plus BD. Okay, and I got the same thing. I just did it kind of in an organized way. A plus B times A minus B, if you multiply this out with FOIL, you're going to discover something interesting. The first two are A squared. The last two are B squared. The inner is going to be B times A, which is AB. And the outer is negative AB. Look at that. AB cancels out with negative AB, and you're left with A squared. Oh, I'm sorry, it's not plus B squared, it's minus B squared because it's negative B times positive B, so it's negative B squared. Okay. SAT loves that one. A plus B squared. So this is like if you have, I have A plus B times A plus B, so it's a little bit different than this one. This one has two different binomials. A plus B squared has the same binomial twice. So that's the same as A plus B times A plus B. If you do FOIL with this, you're going to get A squared for the first. You're going to get B squared for the last. You're going to get, the outer is going to be AB, and the inner is going to also be AB. So you're going to combine these two, and you're going to get A squared equals 2AB. Oh, I'm sorry, it's not equals. It's A squared plus 2AB plus B squared. And then A minus B squared, you have that. So if you do this with FOIL, you're going to get something similar to the previous one, except you're going to get A squared minus AB plus B squared. And so the minus AB combines to be minus 2AB. So it looks almost the same as the last one, except for the middle term, instead of being plus 2AB, is now going to be minus 2AB. The last term is going to be plus B squared anyway. Okay? All right. Again, SAT loves those. Now I'm going to do ACE. So I'm going to expand this. The way I expand it is I use distributive property. I'm going to multiply x squared times x cubed. I'm going to multiply x squared times x squared to x squared. And then finally I'm going to multiply x squared to x squared. Now I'm going to multiply these together. X squared times x cubed, I can add the exponent, so it's x to the fifth. Next one is x squared times x squared, so it's 2x to the fourth. And the last one is just going to be x squared. C. Here I'm going to distribute this. I'm going to multiply the outside with the two inside components. So it's going to be x to the 1/2 times x to the 1/2. Plus x to the 1/2 times x to the negative 1/2. I add the exponents together. So x to the 1/2 plus 1/2 is x to the first. X to the 1/2 minus 1/2 is x to the 0, which is also equal to 1. So it's x plus 1. E. Here I have 3 to the x times 2 and 3 to the x times 3 to the minus x. 2 times 3 to the x minus 3 to the x times 3 to the negative x. Here I have the same base, so I can add these exponents together. So I get 3 to the 0. Here, I do not have the same base, so I cannot combine these. So basically, I have 2 to the 3 to the x minus 1. Okay, and that's all I can do. I can't really do anything other than that. G. Here I'm going to distribute the 2 to the negative x to these two inside components. So I'm going to have 2 to the negative x times 2 to the x plus 5 times 2 to the negative x. So that's going to be, if I can add these two together, so I'm going to get 2 to the 0 plus 5, and then it's going to be 2 to the negative x. So that's going to be equal to 1 plus 5 times 2 to the negative x. And I can't really do anything more than that. Don't try to combine these because you can't. Not the same base. I'm going to multiply this times this times this, and this times this. So I'm going to have x to the negative 1/2 times x squared plus x to the negative 1/2 times x to the first, because x by itself is x to the first, and then x to the negative 1/2 times x to the 1/2, which is x to the 0. So that's equal to, I'm going to add these two exponents together. I'm going to add these two exponents together, and I'm going to get x to the 3/2 plus x to the 1/2 plus 1. 2a. This is interesting. We're going to do FOIL with this, okay? So first we're going to do the first two, and then we're going to do the last two, and then we're going to do the inside and the outside. So 2 to the x squared is the first, negative 3 is the last. The inside would be negative 1 times 2 to the x, and the outside would be plus 3 times 2 to the x. So, can we simplify this? We could a little bit. I mean, we could put 2 to the 2x minus 2 to the x. Oh, look, minus 2 to the x and 2 to the x could be combined. I could combine that. It's like negative 1 of 2 to the x plus 3 of 2 to the x is plus 2 of 2 to the x minus 3. And I could go one step further. I could say 2 to the 2x, and then I could multiply the 2 times 2 to the x, and I could get 2 to the x plus 1, right? Because this is 2 to the 1 minus 3. Let's see, the last one, C. So it's 5 to the x minus 2 times 5 to the x minus 4. So the first term would be 5 to the 2x, right? 5 to the x times 5 to the x. You could add the two x's together. The last term would be plus 8 because negative 2 times minus 4. Then I would have the two middle terms. I would have negative 2, 5 to the x, minus 4, 5 to the x. And so the middle terms could be combined into negative 6, 5 to the x, plus 8. And the first term would be 5 to the 2x. I don't think I can do anything more than that. Okay, so that's it for page 7.